dynamic programming? Dynamic programming is a programming technique that can dramatically reduce the runtime of some algorithms, but not all problem has DP characteristics, from exponential to polynomial. Many real-world problems only solvable within reasonable time using dynamic programming. To be able to use DP, the original problem must have optimal substructure. Optimal solution to the problem contains within it optimal solutions to subproblems. Overlapping subproblems, we accidentally recalculate the same problem twice or more. There are two types of DP. We can either build up solutions of subproblems from small to large, bottom up, or we can save results of solutions of subproblems in a table, top down plus memoization. Let's start with a sample of dynamic programming technique. We will examine the simplest form of overlapping subproblems. Remember Fibonacci? A problem which creates a lot of redundancy if you use standard recursion. Fn is equal to Fn minus 1 plus Fn minus 2. Top-down Fibonacci DP solution will record the each Fibonacci calculation in a table, so it won't have to recompute the value again when you need it. A simple table lookup is enough memoization, whereas bottom-up DP solution will build the solution from smaller numbers. Now let's see the comparison between non-DP solution versus DP solution, both bottom-up and top-down. It's in this C source code. Int non-DP, int n, if n is equal to 1 or n is equal to 2, written 1, else written non-DP of n minus 1 plus non-DP of n minus 2. Top-down DP, int DP top-down, int n, the base case is if n is equal to 1 or n is equal to 2, written 1. Immediately written the previously computed result. If memo n not equal to 0, written memo n. Otherwise do the same as non-DP. Memo n is equal to DP top down n minus 1 plus DP top down n minus 2, written memo n. Fastest DP bottom up, store the previous results in array. Int DP bottom up, int n. Memo 1 is equal to memo 2 is equal to 1. These are the default values for DP algorithm. From 3 to n, we already know that fib1 and fib2 is equal to 1. For int I is equal to 3i less than or equal to ni plus plus, memo I is equal to memo I minus 1 plus memo I minus 2, written memo n. Let us look at matrix chain multiplication. Let's start by analyzing the cost of multiplying two matrices. Matrix multiply A, comma B. If columns A not equal to columns B, then the error message incompatible dimensions should be displayed. Else, for I is equal to 1 to rows A, do for J is equal to 1 to columns B. So loop over the matrix elements, do Cij is equal to 0. For A equal to K equal to 1 to columns A, do Cij is equal to Cij plus Aik into Bkj, written C. Time complexity is equal to order PQR, where mod A is equal to P into Q and mod B is equal to Q into R. The result is matrix C, but mod C is equal to P into R.